So taking this back to area, we want to find these rectangles. We want to find the sum of these rectangles, all right? So we're going to look at our function that we had in the previous lesson, 17 minus x squared. We want to find the area under the curve from 0 to 4, all right? So we're going 0 to 4. And we're going to use 5 rectangles now. All right, well, oh boy. So 5 rectangles. It's not going to end up so nicely here. So we want to find the upper sum. Well, the upper sum here is the left-hand sum. And the lower sum, which is actually the right-hand sum in this case, okay? We're going to probably be using right hand and left hand more than lower and upper. Okay, so the lower sum, or the right-hand sum, let's start with that. Okay, so we want 5 rectangles. All right, so we're not going to be able to draw them in very neatly here. Okay, they'll be, I don't know, something like this: 2, 3, 4. Might go to here, and 5. Well, the 5th one we know is going to go to there. 1, 2, 3, 4, 5. Got it. Okay, 5 rectangles. Now, my drawing is not perfect, okay? Well, the question we want to think about is this. How wide is each of these rectangles? So delta x is going to be the width, 4, divided by 5. All right? So we have 4/5. Now, if we want to find the area of each of these, we'll need to find the value of f at each of these. So this height here would be f of 4/5, because this is 4/5 wide. In fact, each of these will be 4/5 wide, right? 4 divided by 5. So this is f of 8/5. This is f of 12/5. This is f of 4/5 more. That'd be what? 16/5. And this is f of 20/5. All right. So, yeah, there we go. So f of 25th, by the way, obviously is f of 4, which is what we want. That's the end of our interval there. All right. So how do we write this as a summation? Well, we're going to have 5 rectangles. Okay. And we're going to write this as the height times the width. Okay, so the height, each one of these is f of, and we have 4/5. This first one was 4/5 times 1, 4/5 times 2, 4/5 times 3, 4/5 times 4. So this is 4/5 times I. Times delta x. Well, what is delta x? Delta x was 4/5. Now we could use our calculator at this point here, and that's often all we want to do. But let's go through the algebra here, and let me show you how this works, okay? Using algebra, we can replace this here. This is the sum from I equals 1 to 5 of f of 4/5 I. Well, now f was 17 minus x squared. So in this case, 17 minus 4/5 I squared times 4/5. All right, and this probably should be in big parentheses because it's all in the summation. Okay. All right. Well, let's clean that up a little bit here, and let's see. Let's go ahead, and this is equal to the sum of I equals 1 to 5 of 17 minus 16/25 I squared times 4/5. And that is going to be the sum of I equals 1 to 5 of, now let's distribute that 4/5 there. And so we'll have 4/5 times 17. It's getting a little ugly here, but that's okay. 40 and 28, 68/5 minus 4/5 times 16/25. That's going to be 64 1/25 I squared. And now we have the sum of I equals 1 to 5. We're going to split this into 2. 68/5 minus the sum of 64. Now, actually, let's do 2 for 1 here. Okay, let me back this up. So we're going to have the sum of this, but since it's a constant times a function of I, we can pull that constant out. So let's write that as 64 1/25 times the sum from 1 to 5 of I squared. Okay, we're getting close. Okay, well this, we can use our constant rule. So we have our constant times 5 in this case, n. And well, that's easy. 5 times 68/5 is 68. Then we have minus 64 1/25 times, now our I squared formula, remember I squared was n times n plus 1 times 2n plus 1 all over 6. So in this case, n is 5. So we have 5 times 6 times 2n plus 1. So 2 times 2n plus 1. 2 times 5 plus 1, that's 11, all over 6. And these 6's conveniently cancel. So we're almost there. 68 minus 64, and that's 55 times 55, all over 125. Okay, and at some point here, which seems like about right now, probably good to go to our calculator, and we'll get a decimal approximation. And that comes out to be 39.84. Okay, so that's how that works. Okay, so we can do the algebra with it there. What about the upper sum, or what we'll call the left? It is an upper sum, but more specifically, it's a left-hand sum. Well, left-hand sum, again, we're going to do 5 rectangles. So we're going to take 4, and we're going to split into 4/5, is 4 into 5. So delta x, again, is 4 divided by 5, all right? But if we do the left-hand sum here, so it's going to be 4 divided by 5 is less than 1. So it's going to be something like this, split into 5 rectangles, all right? It's going to be something like this. Sorry, this is a left-hand sum. I was drawing the right-hand rectangles again. Left-hand sum is going to go up. Let's see if I can draw some rectangles. Up and over, up and over, up and over. It's going to connect to the left-hand side there. Okay, so that's don't trust those drawings to be accurate, of course, but that's the idea. We have 5 rectangles. They're each, again, 4/5, but their height's a little different. Okay, so we have their heights start at f of 0, right? They start at 0 this time. Okay, so this is f of 0. This height is f of 4/5. This height is f of 8/5. This height is f of 12/5. And this height is f of 4 times 4, 16/5. Okay, so this is 4/5 times 1, 4/5 times 2, 4/5 times 3, 4/5 times 4, and 4/5 times 0. So how can we do this? Well, we can do this a couple ways. Let's write our summation. So the area approximation is the sum of I equals 1 to 5 of, now we got to write an expression for this. Okay, so this is 4/5, not times 1, but 4/5 times 1 minus 1. Okay, so it's 1 less than what the I value is. So let's get a little more room here. So we're going to have 4/5, not times 1, but 4/5 times I minus 1. And that's the height, and the width is 4/5. Another way we could do this is we can also change our index and say this is I equals 0 to 4. And this is f of 4/5. You know what, let me use a different letter here just so we can keep things clear. K, 4/5 K times 4/5. Now if you look at this, the first one will be 4/5 times 0. That would be f of 0. That's this one. Then we go up to 1, 4/5 times 1. That would be this rectangle. And 4/5 times 3, all the way up to 4/5 times 4. 4/5 times 4 would give us 16/5. Okay? So, either one will give us the same answer. Now, let's go to our calculator for this one. Now, the only difference here is if you use this, be careful, you can't use the rules that we had previously. We had a rule that said the sum of I equals 1 to n of I squared is n times n plus 1 times 2n plus 1 divided by 6. But notice this has to start at 0. All right, we won't go into much more different ways in more advanced math. We could spend more time. You could change this. You could peel off the first term and get it to look like this. But keep in mind that this formula has to start at 1. Okay, you can't use this formula in this case if you start at 0. You got to do some more work. Well, let's go to our calculator and let's see how this would work. I'm going to use Desmos. You could use your TI Inspire as well. On your TI Inspire, it's under Calculus and let me bring this over here. Calculus and Sum. That'll give you the sum there. All right. So we're going to make this a little larger first of all. There we go. That should work better. All right. So I'm going to enter my function here. F of x equals 17 minus x squared. Okay. There's my function. And now we can do our summation. So again on the Inspire, it's under Calculus and Sum. In Desmos, it's under Functions. Let's find it. A little small there. There it is. Okay. Let's see. Got to be careful. They're using in here. Okay, so notice that's n equals. I wonder if we could change it. We could probably change that. So if you wanted to change it to match your I, you could. Okay, it's just a letter. There we go. Looks like it's happy with that. I equals, and we're going to go from 1 to 5 of f of 4/5 parenthesis I minus 1, close the parenthesis, close the parenthesis. Probably should do this whole thing in parentheses. Don't want it to calculate improperly. Times 4/5. Okay. So there we have it. Now we know this is going to be an overestimate because those rectangles are above. So we get 52.64. All right. Now, if I'm going to copy that there, and if I change this, and I could change this in a couple ways, by the way. Okay, watch this. I could change this. I can make this 5 into 50. Oh, no, never mind. We have to change more than that. Never mind. Okay, well, let's change that to 4, and let's change that to 0. And we got to take off this minus 1. And notice it's the same thing. Okay, so we get 52.64 for both of those. Okay, All right, so there's our number. We get approximately 52.64. So that equals exactly, actually, 52.64. And they both would, because they're going to calculate the same thing. All right, so there's how we use the calculator and a summation. So a summation gives us a very clean way to write it, and the calculator can compute that very easily. And we can also do the algebra. Sometimes it gets challenging. It would get more challenging with this -1 version thing here. But that's how we do it. So I hope that helps. It is a new kind of thing working with these summations, and we're dealing with some real generalized notions here. So it takes some practice. Don't get frustrated. Keep it up, and you'll get it. Thanks a lot.